Hello, everyone. My name is Hugo Dorado. I'm a researcher of the Biodiversity Seed Alliance, and today we are going to talk about the introduction to data science in agriculture. This is the first video for training a series of videos that we've developed between the Biodiversity Seed Alliance, the Illinois University CIMWIT, and the CCAPS project. So formally, I would like to greet you, and I hope that you enjoy learning this course about data science for agriculture. To begin, many of us have witnessed the great technological changes in agriculture in the last years. If we go back 20 years in time, we could see that the information that the producers received for taking decisions came specifically from the technical assistance that was person to person, even information that could be given to them by nearby neighbors or family members. If we go back to 2020, there are more tools to take decisions of what tasks have to be performed in the crop. Among them, we have technological tools like cell phones, like sensors, and even drones that allow to give a proper monitoring to the crop and to collect information in real time. And throughout time, we've also changed the way that we analyze information in agriculture. The classic way to do it, and that's still being very useful, is based on uh, ex- uh, controlled experimentation. These are studies where some factors are controlled, and then we assess the response that we're interested in, being a material, specific distance to plant the crop, or a practice. Given the context where these experiments are performed under specific characteristics regarding the soil and the climate, these can we can do small scale studies. The new approach also brings the use of non-experimental data or observational data. This is the type of data that has no experimental control. It's the same data that are produced by the producers that can be obtained from the field directly. So, what information are we interested to find out during the life cycle of a producer? We're interested in climate information, soil information, and agronomical management, which are the ones that directly affect the success of their crop, being profitability or the quality of the crop or the yield. If we collected all that information, not only from one producer, but several producers, it's like, let's say, a city or a department would be a field for experimentation where many producers had different and specific management depending on their conditions, and all that information can help us to reveal probably what are the most important characteristics that affect that response that we would like to assess. So, bearing this in mind, we can define large scale studies. These are studies that involve information from several cycles, from several producers, where we are interested in characterizing some climatic conditions, solar radiation, humidity, etc., and other soil variables like the cationic exchange capacity, the structure, and agronomical information like the distance between the crops, fertilization, the amount of monitoring, crop management, and all these variables would show us how the yield is affected, how the profitability or the sustainability are affected, or another variable that we are interested in during our research. So the idea is that all this information from the different cycles could be analyzed by algorithms that allow us to reveal the information that's there, to assess the trends, certain patterns, that in the future could help us to identify what are the most important factors that affect the yield. What are those climatic patterns that are favorable or unfavorable for certain crops or for certain crop managements, or what are those practices that are specific to each site and that are optimal so that every producer can reach their best potential, the best yield. And this is how data science appears as a useful tool in this process for decision making. And it allows us to define a structure from data collection, the processing of the data, the analysis that is implemented on that data in order to obtain those patterns that we're interested in to identify, and also the process in which we take that information that we obtain from that analysis and we take it to the decision makers. And this is the way that we disseminate the information that we find. Data science involves different disciplines like statistics, which is the classical way in how to analyze data mining, which is a newer concept on how to exploit information, but this involves parametric, non-parametric, and computational methods. It's kind of different to statistics, and sometimes it also works with black box models. And there's another concept called big data that's more oriented towards um, storing and analyzing and processing large amounts of data. We're talking about terabytes of information. And also, we also have the concept of machine learning. And this is a series of computational models that computers use to learn certain actions. And these models can also be implemented on databases for trying to reveal those patterns that can be found. And afterwards, we're going to dive into some of these models, statistical models and machine learning models. But all of these are concepts that belong to data science. There are several structures that define the process to generate information based on data. One of them is this standard called CRISP-PM that comes from data mining. And this standard suggests to begin with understanding the problem where different research hypotheses are evaluated. Then we hold conversations with experts and people that are close to the topic. And we assess the variables that are going to be collected, what's the necessary information for the project that we're involved in. And then we start collecting data. And when collecting data, we define the information that's going to be used, if we want to use external sources, or if we're going to collect all the information that's going to be part of the study. After collecting information, one of the longest steps come in this standard, which is data processing. And this step takes a long time because since we are using different structures in terms of the information, different databases, this means that we have to invest more time in trying to harmonize all the information, trying to reduce the errors, trying to control the quality of this information that's being collected. So this is one of the steps that are more time demanding. After data processing, once we have the databases ready, we'll continue with the modeling process where we use the models that we define that are going to be useful to find those relationships, those patterns that we're looking for. So that's the tool that will allow us to produce that information that we're looking for to improve the decision-making process. So we have machine learning, the statistics models, and other computational models that allow to analyze that information. These are the ones that are going to show us the signs. Those signs then are sent to an assessment process that is done with experts and people who are related to the topic. Because many times what we find in those models, they could probably have a good performance, mathematically speaking, in terms of assessing the data that we are analyzing. But in terms of interpretation, we probably missed measuring some specific information that's important that we didn't realize had to be measured in the beginning. So in that case, if we see that the interpretation cannot be strong, we have to begin the cycle once again by understanding the problem. We have to start from scratch to determine what was missing. But if during that information exchange with the experts tells us that that information is valuable and we're ready to disseminate it with the decision makers, in this case would be the producers, or it depends on who we are developing this project for, then we can go to the deployment step where we use the effective communication methods so that these people can take decisions. we cannot go directly and speak in mathematical terms, but it's important to understand that we have to do some additional work on how to translate that information so that it can be useful in the future to take decisions. Now, regarding the information, we can classify the information in two different ways. One would be the primary information, and this is information that we generate with the specific objectives in mind that involve the study that we are developing. And the common way to do this in agriculture would be based on harvest records. It's the one that we would like to use the least, but it's the one that's mostly used. And this is when the technician or the producer goes and they have harvest records, and they store all that information in a piece of paper. And this information has a big challenge, and it's tried to translate this into a digital format that can be analyzed. And the use of web platforms have become a little bit more popular for collecting information and doing analysis and reporting. So there are producers that use some software platforms that are capturing a lot of information already, and that this is direct information that comes directly from the producers. Others are using mobile applications, for example. It's another easy way to collect information. And there are some applications that work outside the coverage area. They don't need to be connected to the internet on a permanent basis to generate data. And another way would be drones. Drones have a specific flight programs programmed in them. Um, and there's a specific strategy to capture this information with a specific purpose in mind. And we have the secondary information. And this is the information that's not captured with the objective that we have to do research, but it's information that's available nevertheless, and it helps us also. The first one would be remote perception. This would be satellite imaging, all the information that we can extract from vegetable indexes that can be associated to the crop. This information is being collected, but not with a specific purpose in mind, because it could be for many different objectives. The same thing happens with the weather stations from the different national institutions that every country has. That's information that in the end is available there and can be also useful depending on what are their traits to try and analyze the data for agriculture. There's additional information that's free, and these are public databases. I've not named them here yet, but there's one that's called WordClim, etc. And these are estimation based on historical data and based on satellite imaging. And these images are processed and they're readily available to use them as a resource for this type of analysis. And they work very good. But we always have to go through a information quality process to use the secondary information. And the last one would be historical data. Sometimes there are organizations of producers that have collected information for many years, and they're not taking advantage of that information in their full potential. But sometimes this information is used only for doing descriptive analysis, basic analysis. But if you and I use this with a data mining approach, they could probably have more potential to be exploited for the decision making process. And something else to highlight is that currently we are more and more motivated to share information, to share data. There are many initiatives on different countries with open source, open data initiatives. For example, the World Climate Information that's available without any restriction. But right now, there are many institutions, public institutions. I know that in Mexico, when I was working with the data with Masagro, a project that we had jointly with CIMID, I noticed that there was information from the different government sources that um, push forward this open data. But there's a quality component that has to be assessed when you use secondary information. But that information is one that we have to take into consideration. because they've made a huge effort to collect all this information. It can be useful for data analysis. Regarding the methods of analysis, I already mentioned that there are several approaches. Among them, we have the traditional methods, like statistics, like multiple linear regression, factor analysis, mixed models. And these are methods that have a strong theoretical approach. They have strong concepts in terms of data analysis, but they have a constraint. And many times these are based on suppositions, statistical suppositions like the Gauss Bell, linearity between the variables, like the independence of those observations. So those are the constraints. And when you work with a lot of data, and you don't especially know how the processes are carried out there, many times you could be limited by those traditional methods. And there's another approach, which are machine learning based methods. This is an automatic method with artificial neural networks, random forest, and we're going to go over this in the data mining module that's also part of the course. But these are methods that many times have a disadvantage because they're black box methods. This means that they're not as transparent as the traditional methods. These are computational methods based on certain optimizations that sometimes it's hard to understand the relationships that occur there. Sometimes this is used with specific purposes, but the advantage is that these are uh, supposition free. They don't require for the data to follow special distribution. They don't require so many suppositions as with the initial data. And both tools can be useful for data. And the second one is more complex than the first method. So if I have a problem and have data, I shouldn't go directly to the most complex ones, but first I should remove the most basic and then move to the most complex. Another huge challenge that we have in terms of the flow information from data science is how to reach the end user. And the biggest challenge in agriculture is how to reach the producers, how to convince the producers that using data and taking decisions based on that data is very useful. Why? Because there are different groups of producers. We have producers that aren't tech savvy, that have mid knowledge, or who are very advanced in the use of technology. So, based on our experience, we've identified a series of methods to try and deliver that information to the producers. For the producers that aren't so agile and tech savvy, uh, the idea is to train the technicians. They should be the ones who understand this information, and they have to convey the information directly in the terms that they use to communicate. And there are other activities where the producers are, like the field schools. In Colombia, we have technical tables for agronomy and climate that we are going to start implementing in Mexico with the help of CIMID. And this is a space open for producers to gather with the experts and to assess the climate forecast. And based on this forecast, they'll define how the sowing will proceed the next season. So these are spaces that do not require so much technology per se, and that can be useful so that small and mid holders can have access to information based on data. And there are other producers that are in intermediate level of knowledge that use mobile applications. Like, for example, WhatsApp is used very often in the field. So we should take advantage of these alternatives to convey that information. For example, with chatbot, that's another idea that we're trying to push forward recently. And in Asia, they use something that's called IVR, interactive voice response. And these are calls that are made to the producers when the producer talks to an operator, that usually is a machine, but it gives them information. They give them possibility to choose the information that they need based on several options. And there's another type of user that aren't necessarily producers, like, but for example, the scientific community, people that are work in the government. So these people can also be delivered information so that they can keep on working on these topics through interactive visualization, blogs, press releases, scientific publications. So every group of decision makers or stakeholders should be given certain technologies. And in terms of data, there are some ethical aspects that are very relevant. So it's important that at the moment when capturing data, the producer should have this flexibility of being able to know, update, rectify, and delete their personal data. They should have that option enabled. And I think in Colombia and most of Latin America, we have the law of habeas data that allows to have that standard, so that the people that share information should have the freedom of deciding what's going to be done with that information. And at the moment of publishing the information, we also have to pay attention that this information has to be anonymous, and there has to be a privacy policy for that data, because this information can be used for commercial means. So we don't want um, to share uh, the information of the producer, like cell phone numbers, like addresses, geographical coordinates. So we have to be very careful when we manage this information. Data science, just like any type of science, has certain limitations. First of all, the success of the results depends mostly of the quality of the data. If we don't have good information, we won't be able to find any relationship that allows us to contribute to the problem that we want to solve based on that information that's being collected. So, bearing this in mind, we try to avoid to have by a bias and not to favor specific population that can become a constraint during the analysis. And we should also try that at least the variables that are required should be included within the analysis that we are performing. And the fact that the results found based on that data applies for that universe of study. This limits the possibility to extend that objective population. For example, if our information is collected based on the data of the producers in Chiapas, we cannot extend that knowledge to Guanajuato or to other countries. First, we have to understand, we have to define if these are similar conditions for in terms of climate and production, and then we can export part of that knowledge to try and apply it. So we also have to be very careful with this, because it doesn't work necessarily like the models that are based on crops that have more information about the crop, specifically physiological information. And in that case, uh, probably you can leave that universe of study where the data is being analyzed. And the third point, that's also a limitation, is some objectives that we may have with the data analysis required to have access to information that can be costly. Probably not all information is available or not freely available. So this can limit what we can do based on the data. For example, someone that wants to implement data science in their business for improving their income, they cannot say, okay, I'm going to set up a data project here, because they'll probably need experts in data analysis. They probably need a system that allows them to monitor all transactions. So sometimes this is going to require some additional costs that can be a disadvantage if you are going to begin from scratch. So as a summary, the key points of this presentation is, first of all, we identify what's the importance of observational data in agricultural research. And that was presented as another approach to the classic approach that allows us to compile information directly from the producers and not necessarily doing trial and error work. The second is that we were able to identify various sources of information, not only primary but also secondary information that can be very useful for agriculture and for solving the problems that we want to assess. The third one, we were able to define the concept of data science. We already saw that it involves several disciplines and several terms that we're going to dive in. And the fourth is that we were able to define and comprehend the process of information to transform them into information that can be used to take decisions. So we know that there's a step where we have to understand the problem, then another step to collect data for processing, modeling, assessing, and if we do good with what we found, we can proceed to the deployment of the information. We also identified and we know that the information that we require is our responsibility. We talked about ethical aspects that we have to take into consideration. And in the last slide, we talked about the limitations. So with this, we finished the first video of this course for data science for agriculture. I hope that you liked it, and I'll be open to receive questions.